Hello everyone, and thank you very much for joining this session. OpenCAPI Release 3 includes the PKI security method functionality. With this demo, we want to showcase how APIs exposed by a provider can be securely accessed using the PKI method through OpenCAPI. Release 3 includes the support of PKI security method. This new version gives, then, to provider the capability to grant access to the APIs by using PKI method. OpenCAPI will select during the creation of invoker security context the security method to be used. If there are more than one security method allowed by API published, and invoker also support more than one, the OpenCAPI will prioritize one according to their internal priority order configure. If provider wants to use this security method, AEF must implement the AEF security API defined by 3GPP and publish it together with the other APIs exposed by this AEF. As defined at TS 33122, if invoker access if invoker access to published API by using PKI or PSK before reach endpoint, it should request the authentication initiation request to AEF by sending a post to check authentication endpoint. In this slide, we can see the block diagram of the demo components. At the center, we have the OpenCAPIF, the CAPIF core function, with all the interfaces involved. At the right, we have the invoker, which will be simulated by Postman in this demonstration. And at the left side of the picture, we have the provider client. For this demonstration, we have created a simple provider composed by two components. The Nginx that will manage the CAPIF2 interface to be connected through Invoker, and an AEF server developed in Python Flask, which connects through CAPIF 3, 4, and 5 interface to OpenCAPIF to make the registration and publication of the API exposed. This provider implements the AEF security API defined by 3GPP. We can review now the current flow involved in this demonstration. The first step will be onboard the invoker, and after that, register the provider. After onboarding invoker and register the provider, the next step is discover APIs by invoker. We can see there the APIs published, and then invoker can create the security context to access them. After creation of the security context, invoker can reach using the check authentication API the AEF provider, sending the API invoker ID. This triggers the logic inside the EAF provider to get the security information related with this communication and store the information inside the AEF provider with this information, and also check the security method. After that, invoker receives the 200 OK response, and then it can reach the information API. Then we can start the demonstration. The first step is to check the CAPIF core function is running locally. Next step is run the client PKI for demonstration. Checking the logs of client PKI, we can see there are all the APIs loaded at Flask server. We can check the APIs published by Flask here in the web page. We can see check authentication, revoke authentication, start client PKI, and information, which is the endpoint under test. We can start. The first step, as we saw in the flows, is an administrator must create a user. With this, we get a token. This access token will be used in the next operation to create a user. In this case, we will create a user with this username, testing, and the password. Using this endpoint of the CAPIF core function, with the authorization previously taken, this token, we can request that creation. We can see here the user is registered successfully and the unique ID. After this, we can onboard the invoker just requesting the token to access CAPIF core function. This will give us an access token, the CA root, and all the URLs to be used for different operations. In this case, the onboarding must be using this endpoint, the API invoker management, V1 onboarded invokers. Then the next operation is the onboard of the invoker. And then in the authorization, we will use the access token. We can see 201 created. This means the invoker is properly onboarded. And here we get the API invoker certificate to be used in the next operation made from the invoker to OpenCAPIF. Now we have the certificate. We need to configure the Postman to send the discover request. For this, we must configure the Postman here in settings, certificates. We must put here the CI cert, and also we must add the certificate here. CAPIF core and select the CRT. This, the client cert, CRT, and the key. This is the private key. Okay. Then we can send the discover request. And we can see we receive the 404. This means there are no API published. Then the next step will be send the start client PKI. This puts the registration of the provider through OpenCAPIF. For here, we can send this and see the response. Provider registered successfully with 200 OK. The logs, for example, in the client PKI, we can see here. AES security start client PKI, validating parameters. These logs are related with the SDK, the OpenCAPIF SDK, which retrieves the certificate and also made the registration of the provider here and store all the information related. And the last lane, we can see the APF ID and the AEF's IDs. Okay, we can remember this, for example, and we can check with a discover from the invoker side again. And now we see that we have one API published. The API name is the testing PKI with the AF ID, the same that we saw in the logs. In resources, we can see the check authorization with the endpoint to be used and the next steps, the revoke authorization, and also the information endpoint. On the other hand, we can see here the security method allowed by this API, which is only the PKI, and also the domain name to be reached by the invoker, and the description. With this information, we can request by the invoker side the creation of the security context. This security context must select the preferred security methods by invoker. In this case, will be PKI, setting up the AEF ID and the API ID. And with this, we request OpenCAPIF the creation of the security context to relate the invoker and the AEF. Here we have the 201 created. This means the security context is properly created. And we can see in the body of the response the cell security method PKI. This means after receive the request of creation of the security context, OpenCAPIF checks the preferred security methods and the methods allowed by the API exposed and select the one according to this intersection and priority. At this point, we can send the initial message that we must send as it is defined in technical specification 33122. We can see here the endpoint to be used is the check authentication, and we must include in the body the API invoker ID. This request will be sent directly to the client PKI, the domain name that is included in the API publisher. We receive the 200 OK with this body. This means after this check, this invoker is allowed to try to access the API exposed by provider. We can check also the logs inside the client PKI. And here we can see this request, check authentication, validation parameters. This launch some other requests, like the get request to OpenCAPIF to get the security context. Here we can see the security context, the security information retrieved from OpenCAPIF, indicating the AEF allow, the API ID allow, the selected security method, and the authentication info. This key includes the CA to be used to check the certificate when the invoker tries to reach the endpoint that is subscribed. And on the other hand, the provider store all this information inside a file to be used in the next request. Okay, then the next step is try to reach the information endpoint, but we need to use the certificate of the invoker. To allow this using Postman, we need to configure here in settings a certificate for this endpoint. Okay, the client PKI dot org and this port. For that, we need to select the CRT, the certificate, and also the private key, which is this one. With that, all the requests sent to this endpoint must use the invoker certificate. Now we can send this request, and here we have 200 OK. This means all is working fine, and this is the body of the response. Info, sample information. We can check the logs. Here, the invoker reach directly the AEF at this endpoint, the information endpoint, and retrieve all the information. Here we can see the client certificate sending this request. On the other hand, this certificate includes the API invoker ID in the common name, and with this API invoker ID, searching in the information store previously, find which CA must be used to verify the certificate. After that, the certificate is validated using the CA. If all is okay, it is decoded, and also some checks were made, like if it is the AEF that is allowed to be used by the invoker. And after that, the information is sent in the response. On the other hand, we can try to send a not valid certificate. In this case, this is a Postman configuration. We configure here in settings certificates this endpoint, which is invalid client PKI.org 8443 with not valid certificate. You can see here test cert. This is not valid certificate. This request will reach the AEF, but using a different certificate. If we send the request for information, we receive 403 forbidden, indicating the invoker with this ID, which is this certificate that I configured previously. Should call check authentication endpoint before accessing endpoint. If we try that, it will say there is no security content and this invoker is not allowed to reach the endpoint. And that's all. With this, we have finished the demonstration of the PKI feature. As just a summary of the conclusions, at the end of this demonstration, we have shown how a provider can publish APIs using PKI method through OpenCAPIF, how an invoker once onboarded can securely discover and consume those IPs, and how the AEF acts as the enforcement point, validating the invoker certificate and ensuring secure communication. This validates the full PKI-based security flow in OpenCAPIF in compliance with the 3GPP specification. Thank you very much.